Today we'll discuss about the Chapter 8 Mathematical Modeling. Our group members have Shani and Tambosuit. This topic will discuss about the introduction of mathematical modeling and solve real-life problems through mathematical modeling. What is mathematical modeling? A mathematical model is a mathematical relation that describes the real-world situation. For example, I equal to PRT is a relation between simple interest and the other three quantities. The P is a principal, the R is a rate, and the T is time. A mathematical model is a representation of a system or scenario that is used to gain qualitative and quantitative understanding of some real-world problems and to predict future behavior. There are some important questions around the world that are not answered. For example, what is the effect of rising sea levels on the coastal regions of Malaysia? How much will it cost to go to college or university in 10 years? Will the population in Malaysia surpass 40 million? Is it possible to identify the personality trait of cybercrime victims by studying the behaviors of the web surfers? Usually, we will want to solve problems directly based on our existing knowledge. However, not all problems could be solved in easy way. Therefore, we shall model the problems as mathematical problems and solve them mathematically. Hence, the solutions obtained are interpreted back to become solutions for the original problems. Not all real-world problems can be completely solved through mathematical modeling. However, mathematical modeling helps to make decisions precisely, make assumptions accurately, understand phenomena related to certain problems well, define problems occur or gain knowledge about the problems. How long does it take to clean up an oil spill in the ocean? It is an open-ended question and do not have enough information to answer. It is also a real-world problem and do not have complete information to solve it. So we have to use both mathematics, knowledge, and creativity to solve it. The following flow map shows the process of solving problems through mathematical modeling. The yellow arrows show the sequence of the process step by step, while the blue arrows mean repetition of the earlier part of the process where new information is obtained or an error is occurred. First is identifying and defining the problems. When the problem is identified, the information needed for solving it is easier to be found. Second, making assumptions and identifying the variables. Assumptions are made to reduce complexity in building mathematical models. We choose what is important and ignore what is not important in modeling the problems. Variables are identified to help understanding the relationships between equations. Third, applying mathematics to solve problems. Use mathematics knowledge, geometric tools, smartphone applications, and computer software to solve problems. Fourth, verifying and interpreting solutions in the context of the problems. Models or equations obtained are tested by substituting possible values to know whether the models can be used to solve the identified problems. Fifth, refining the mathematical model. Choose a most suitable model for the current situation. Determine the model obtained is the best regarding the assumption made and it does not reward much if minor changes are done on the assumptions made. 6. Reporting the findings. Prepare a report for the chosen model. In the report, explain in detail the problem solved, the steps involved or techniques used, and the final result. Other than that, state the assumptions made, the variables used, and the solution model to problems as well as the findings analysis. In addition, state the strengths of the chosen model and its weaknesses they are fixable. Example 1. The grocery store which is far from your house sells a pack of 10 kg rice at a lower price than the one closer to your house. Is it worth the drive for the cheaper deal? Identifying and defining the problems. The price of a pack of 10 kg rice and the cost of petrol. Determine the distance from the two stores to your house respectively. Find the information needed from the internet. For example, the price of a pack of 10 kg rice from each store, the distance of each store from a house, the current petrol price, the car's petrol consumption rate, and so on. Next, making assumption. The route between the house store A and store B is a perfect straight line. Driving car to the store. purchasing the same number and brand of rice at store A and store B. Identifying the variables. Let S equal the distance between store A and store B. P1 equal to the price of a pack of 10 kg rice at store A. P2 equal the price of a pack of 10 kg rice at store B. And equal the petrol consumption rate of the car in km per liter. And equal to the number of packs of 10 kg rice to be purchased. Capital letter H equal to the current petrol price in Rm per liter. Capital letter S equal to the difference in price in Rm for purchasing the pack of 10 kg rice at store B as compared to store A. Capital letter T equal to the difference in the cost of petrol in Rm for driving to store B as compared to store A. Applying mathematics to solve problems. The price of a pack of 10 kg rice. Store A, 25 ringgit 95 cents is P1. Store B, 23 ringgit 99 cents is P2. Let the quantity of 10 kg rice to be purchased be 2 packs is N. The price to be paid. Store A, 2 times 25 ringgit 95 cents equal to 51 ringgit 90 cents. Store B, 2 times 23 ringgit 99 cents equal to 47.98 cents. Therefore, by purchasing the rice at store B, one can save 51 ringgit 90 cents minus 47.98 cents equal to 3 ringgit 92 cents is capital letter S. Let the distance between store A and store B be 6 km, is known as S. The petrol consumption rate of a car be approximately 17.6 km per liter is M. The current petrol price be 2 ringgit 8 cents per liter is capital letter H. Petrol needed for the 6 km route equal to 6 km divided by 17.6 km per liter equal to 0.341 liter. Cost of petrol for the 12 km two-way route equal to 0.341 liter times 2 ringgit 8 cents divided by liter times 2 equal to 1 ringgit 42 cents is known as capital letter T. Therefore, we can save 2 ringgit 92 cents minus 1 ringgit 42 cents equal to 2 ringgit 50 cents by purchasing 2 packs of 10 kg rice at store B.
Verifying and interpreting solution in the context of the problem. The resulting mathematical model is as follows: S equal to bracket P1 minus P2 bracket times N. T equal to S over M times H times 2. If X bigger than T, then it is sensible to drive to store B to purchase rice and save more money. If S less than or equal T, then we should not drive to store B to purchase rice. Example of using the model: S equal to P1 minus P2 and times N. So it is equal to 25.65 minus 33.99 and times 2. The answer is 3 ringgit 92 cents. The second one is T equal to S over M times H times 2. Is also equal to 6 over 17.6 times 2.08 times 2. So the answer is equal to 1.42 ringgit. Since S is equal to T, you should save more money by purchasing rice at store B. Hence, it is sensible to drive to store B. Thus, the mathematical model is able to solve the problem. Further exploration from the mathematical model. Number 1. If all the variables remains the same, how far can store B to be located so that it is an optimum choice? The solution is P1 minus P2 times N larger than S over M times H times 2. 25.95 minus 23.99 times 2 larger than S over 17.6 times 2.08 times 2. So the answer is S is less than 16.6 km. This means that if the distance between the two stores is less than 16.6 km, then it is sensible to drive to store B to purchase rice. Number 2. What is the maximum price of a pack of 10 kg rice at store B that will attract a person drive to store B to purchase it? Use the same solution. P1 minus P2 times N is larger than S over M times H times 2. 25.95 minus P2 times 2 is larger than 6 over 17.6 times 2.08 times 2. So the answer is P2 is less than 25 ringgit 24 cents. This means that if the price of a pack of 10 kg rice at store B is less than 25 ringgit 24 cents, then it is worth to drink. Therefore, the above medical model allows us to not only answer the question of it is worth it for the given situation, but also allow us to determine other factors that support or oppose the decisions to drive further to purchase the rice. Refining the medical model, the assumption made regarding the route between the house, store A and store B is a straight line needs to be revised. If the route between the three places is not a straight line, how does that impact our model? If new assumptions are being made, then the model needs to be revised to reflect the change. The last one is report the findings. Use symbol and diagram when necessary to report the finding. The symbol and diagram will depict the whole modeling process until it leads to result. Every model has strength and weakness. What is important is that the model identifies those strengths and weakness in the report. For example, first one, the value of a person types is not considered in this model. It is road driving an extra 12 km for someone to save 2 ringgit 50 cents. According to this model, saving 5 cents is considered worldwide. Number 2 is the model did not account for any environmental consideration. It is environmentally responsible to drive an extra 12 km just to save 2 ringgit 50 cents. This model did not account for environmental effort such as effort to reduce carbon emissions. Functions that apply at mathematical modeling. Linear function is mean that a graph resembles a straight line. Second is quadratic function, a curved graph in the form of parabola. The curve may rise and then fall or fall and then rise. Second is exponential function, a curved graph illustrating an increase or decrease in values of data at a sharp rate. The exponential function can be written in the form of equation y equal to x, where is a positive real number and not equal to 1 and c is an initial value. For example, if c equal to 1 and a equal to 2, graph y equal to 2x is shown as the diagram at the right side. Example 2. Amin traveled 405 km on 45 liters of petrol in his car. If Amin wishes to go to a place which is 198 km away by car, how much petrol in liter does he need? Solve this problem through mathematical modeling. First, we need to identify and defining the problems. Second is making assumptions and identifying variables. Third is applying mathematics to solve the problem. Fourth is verifying and interpreting solution in the context of problem. 5 is refining the mathematical model. 6 is reporting the finding. First, identify the defining problems. Determine the volume of petrol required for 198 km. The farther the travel, the more petrol that required. Thus, the amount of petrol is very directly with the distance traveled. Second is making assumptions and identifying variables. Assume that driving speed for both 405 km and 198 km roads are the same. X represents the distance traveled while Y represents the amount of petrol required. Y vary directly with X, hence Y equal to Kx where K is a constant. Third is applying the mathematics to solve the problem. Substitute Y equal to 45 and X equal to 408. X is equal to 405 into Y equal to Kx this equation. 45 equal to K bracket 405 bracket K equal to 45 over 405, so K is equal to 1 over 9. Therefore, the equation is Y equal to 1 over 9x. This equation describes the relationship between the amount of petrol required and distance traveled when X is equal to 198, Y is 1 over 9 bracket, so it's times 198, so equal to 22 liter. Hence 22 liter petrol is required to travel 198 km. 4 is verifying and interpreting solution in context of problem. We may not able to use the linear function model Y equal to 1 over 9x in all situations. For example, if the 405 km road is through towns and cities, and the 198 km road is through highway, thus the car will use up petrol at a fast rate in the first road compared to the second road. When this is translated to the real-world situation, the linear function model obtained is not suitable to solve this problem. 5 is refining mathematical model. In this problem, we are not able to refine the model due to limited information given. In the last is reporting the findings. Report the findings of the problem solving based on the interpretation of solution as shown in the preceding sections. As the conclusion, mathematical modeling process is start to identify and define the problem. Second is making assumption and identifying the variable. Thirdly is applying mathematics to solve the problem. 4 is verifying and interpreting solution in the context of the problem. 5 is refine the mathematical model. If not, so we reporting the finding until the end. That's all.